Hello everyone, welcome to this tutorial. We have two exponential equations here to solve for x. The first one, we have 9 all over 25 to the power x squared plus 4x multiplied to 125 all over 27 to the power x plus 4 equals to 1. Okay, let's take the first one. 9 all over 25 to the power x squared plus 4x multiplied to 125 all over 27 to the power x plus 4 equals 1. If we look carefully, 9 all over 25 is the same as 3 all over 5 all squared. Now it was raised to x squared plus 4x multiplied to 125 all over 27 is 5 all over 3 all cubed multiplied to x plus 4 equals 1. Okay? All right, so here we have 3 all over 5, and here we have 5 all over 3. We want to make the basis to be the same or uniform. So either we convert 3 all over 5 to 5 all over 3, or we convert 5 all over 3 to 3 all over 5. All right, so I want to maintain 3 all over 5, so I need to convert 5 all over 3 to 3 all over 5. We are going to need the law of reciprocals. The law of reciprocals, which says a to the negative n is equal to 1 all over a to the n. This law is going to help us to convert 5 all over 3 to 3 all over 5. Okay? Now, 5 all over 3 is the same as 1 all over 3 all over 5. Now, look at it carefully. So, if we now follow the right-hand side of this law, this is the right-hand side. So to bring it to the form of the left-hand side, it means we're going to raise, this is the same as 1 all over 3 all over 5 to the power 1. And so applying this law to bring it to the left-hand side, it will be 3 all over 5 to the power negative 1. Okay? So 5 all over 3 is 3 all over 5 to the power negative 1. So we have now brought it to the same base, 3 all over 5. So now in this, in the place of 5 all over 3, we are going to write this. So our equation becomes 3 all over 5 to the power 2 into x squared plus 4x. All of that multiplied to, in the place of 5 all over 3, we're going to write 3 all over 5 to the negative 1 times multiply to this power, multiply to 3, multiply to x plus 4. Okay, so we apply the power of power laws. This power will have to multiply out that power. So we have 3 all over 5 into 2 multiplied there is 2x squared, 2 multiplied there is 8x times 3 all over 5 into negative 1 multiplied to 3 is negative 3 multiplied to x is negative 3x. Negative 1 multiplied to 3 is negative 3 multiplied to 4 is negative 12. Is equal to 1. Okay, so our equation now has the base 3 all over 5. But we also know that we want to convert 1 to an index number whose base is 3 all over 5. And we also know that any number raised to the power 0 is 1. So to bring in 3 all over 5 here, we're just going to write 3 all over 5 raised to the power 0 using this law. All right? So finally, we obtain an equation with the same base 3 all over 5. So we can now go ahead and apply the law of multiplication. When the bases are equal, we add the powers. So we have 3 all over 5 raised to the power 2x squared plus 8x. We're adding that power, so it becomes negative 3x minus 12 is equal to 3 all over 5 to the power 0. Okay, now let us simplify this power to have 3 all over 5, 2x squared, 8x minus 3x, 5x minus 12 is equal to 3 all over 5 to the power 0. Look at this level. We now have this index expression equal to this index expression. The bases are equal, so it therefore means that the power should also be equal. So this means, therefore, that the power here, which is 2x squared plus 5x minus 12, should be equal to the power on the right-hand side, which is 0. Here we obtain a quadratic equation. You see how beautiful it is? It all started as an index equation, and when we apply the laws of indices carefully, we arrive at a quadratic equation. That's the beauty of mathematics. We take one question and we evaluate two topics. All right, let us solve this quadratic equation. We all know the factor method. The factor method, we get the factors of AC. What is AC? AC is 2 multiplied to negative 12. So that gives us negative 24. And so we are going to list out all the factors of negative 24. Okay? List out all the factors of negative 24. So we're going to get plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 8, plus minus 12, plus minus 24. Okay? So we have 2, 4, 6, 8, 10, 12, 14, 16 elements. So we have 16 elements from which to make a choice that responds to a condition that the product is negative 24 and the sum is positive 5. All right? From these elements, there is going to be only two elements here that will respond to this condition. And those are the two that we're going to choose. So if we look at it very well, we're going to have the only choice that goes here correct will be the only choice that is acceptable is uh, 8 and negative 3. Okay, these are the only two elements from this set whose product will give us negative 24 and whose sum will give us 5. Okay, so let's clear off space here and continue our solution. Now, having made the choice of 8 and negative 3, we are going to rewrite. We're going to rewrite this our equation, replacing 5 with plus 8 and negative 3. So we have 2x squared plus, in the place of 5, we say 8 minus 3x minus 12 equals 0. Okay, open out this bracket, we have 2x squared plus 8x minus 3x minus 12 equals 0. Now we factorize the first two terms and the next two terms. When we look at the first two terms here, 2x is common. So we'll bring out 2x. When we factorize out 2x from here, we have x. When we factorize out 2x from here, we have plus 4. Now when we look at the next two terms, we see negative 3 is common. So when we factorize negative 3, when we remove negative 3 from here, we have x. When we remove negative 3 from here, we have positive 4. Okay? We should always try to check to see if our factorization process is well done. by opening this bracket. 2x multiplied to x is 2x squared. 2x multiplied to 4 is 8x. So this factorization is correct. Negative 3 multiplied to x is negative 3x. Negative 3 multiplied to positive 4 is negative 12. So this factorization is also correct. Now the factorization process continues. We have x plus 4, x plus 4. So x plus 4 is common. So we'll bring out x plus 4. When we remove x plus 4 from here, we'll have 2x. And when we remove x plus 4 from here, we'll have negative 3. Okay, so here are the two factors of that quadratic equation. Now, pay attention. We're asked to solve for x and not to factorize. So if we have the product of two factors giving us 0, then either x plus 4, the first factor is equal to 0, which therefore means that x is negative 4, our first solution, or the second factor, 2x minus 3 equals 0, which now also means that x is equal to 3 all over 2, our second solution. Okay, so we got the two solutions of this exponential equation. The two solutions are x equals negative 4 and x equals 3 all over 2. Okay, all right, so now let's look at the second question. The second question, we have 25 to the x minus 5 to the x is equal to 20. Okay, so here we have base 5. We can always change 25 to an index number whose base is 5. We all know that 25 is 5 squared, but 25 was raised to the x. Power of power law, this power multiplied to that, so we have 5 to the 2x minus 5x is equal to 20. 5 to the 2x is the same as, we want to make things to look uniform in terms of 5 to the power x. It's same as 5 to the x squared. Okay, so even right at this level, we could have just swapped positions. The x come in and the 2 go outside. That's what I've just done here. The x enter and the 2 go outside. Okay, minus 5 to the x is equal to 20. So we see another quadratic hiding here. It's a quadratic equation hiding here. So to bring it out clearly, let us make the substitution y equals to 5 to the x. So wherever we see 5 to the x, we're going to write y. So this one becomes y squared minus y equals 20. We'll bring in 20 this way. We're going to have y squared minus y. This is plus 20, bringing it inside becomes minus 20 is equal to 0. Now, we have the quadratic here in a much more clear manner. So we have to proceed. I can either use the quadratic formula or the factorization method. So I want to use the factorization method. So your AC, again, this time around is 1 multiplied to negative 20, which is negative 20. So we're going to get factors of negative 20 whose sum is negative 1 and whose product is negative 20. So can we list out the factors of negative 20? We have plus minus 1, plus minus 2, plus minus 4, plus minus 5, plus minus 10, plus minus 20. Okay, those are the factors, plus minus 20. Those are the factors of negative 20. So we got 2, 4, 6, 8, 10, 12. There are 12 elements. Once more, we're going to choose 2 from this set that must respond to the condition that their product is negative 20 and their sum is negative 1. Okay, so the choice that goes best there is negative 5 and positive 4. Okay, now let's check. The product of negative 5 and 4 is negative 20. So this first condition satisfied. The second condition, the sum. Negative 5 plus 4 gives us negative 1. All right. So these are the only two elements on that set that responds to these two conditions. And so will help us to factorize this quadratic. So now we rewrite our quadratic. In the place of negative 1, we're going to put negative 5 and 4. So we have plus negative 5 plus 4 multiplied to y. Okay, minus 20 is equal to 0. So you have y squared minus 5y plus 4y minus 20 gives us 0. So we factorize the first two and we factorize the next two. Here y is common, so we have y minus 5. Here 4 is common, so we have 4 into y minus 5 equals 0. Y minus 5 is common again. We'll bring it outside. We'll remove y minus 5 from here, we'll have y. We'll remove y minus 5 from here, we'll have 4 equals 0. So we have two solutions. Y is either equal to 5 or y is equal to negative 4. Now, our work does not end here. We have to solve for x and not y. So we have to go back to this substitution and plug in these values of y to be able to solve for the corresponding values of x. Now, let's first write the substitution. Y is equal to 5 to the x. So when y is 5, let's put it there. When y is 5, we now have 5 is equal to 5 to the x. 5 is the same as 5 to the power 1. So now we have 5 to the power 1 equals 5 to the power x. It's an equality. The bases are equal, so the powers must also be equal. Therefore, our first solution is x equals 1. Now we also put in the second value of y when y is negative 4. So we have negative 4 is equal to 5 to the power x. Clearly, this is impossible. There's no index expression that will give us a negative value. So impossible. Okay, so finally there is only one solution to that second equation. 25 to the power x minus 5 to the power x is equal to 20, and that only one solution is x equals 1.